My name is Faith McFadden. I'm in section B of your class. So I'm going to make a non-Newtonian fluid, and I'm going to describe the differences between a Newtonian fluid and a non-Newtonian fluid using the notes I've taken. So a Newtonian fluid has a constant viscosity and it doesn't change no matter how much pressure that you apply to it. Therefore, it doesn't compress. Whereas a non-Newtonian fluid is the opposite. So the viscosity does change with the amount of pressure that you apply. The most common everyday example that you use of a Newtonian fluid would be water, or at least you should use it every day. Okay. I cracked myself up. Okay, anyway, so obviously water doesn't change viscosity because it's a Newtonian fluid. The amount of pressure you can put on water as a Newtonian fluid is negligible. Other examples include mineral oil, alcohol, and gasoline. And then non-Newtonian fluids can be broken up into 4 categories. The most well-known category, at least to me, would be the dilatant category. These non-Newtonian fluids get thicker when force is applied. Then there's also pseudoplastics, which are the opposite. They get thinner under the same conditions, so when force is applied. And then you can further break those down into 2 more categories: rheopetic, and they're like dilatants. And then there's also thixotropic. With rheopetic and thixotropic, they're still the viscosity changes, but it doesn't change immediately. It changes over time with increasing force. So common examples of these non-Newtonian fluids for dilatants includes oblec, which is sounds like the scientific name in a sense of a colloid, or maybe it's the regular name. I've heard colloid a lot. But also quicksand and silly putty. And then for pseudoplastics, this was a shocker to me, ketchup, because the viscosity of ketchup changes with each ingredient that you add. So you can't make that like in a large mass, because no, it doesn't work. And then for the rheopetic, increased pressure over time. A good example of that is cream. Cream turns into butter over time with more pressure. And then of a thixotropic, examples include cosmetics, asphalt, and glue. Now I am going to make a non-Newtonian fluid using Arm & Hammer, pure baking soda, and water. I do not have food coloring, so I'm going to make it, and then I'm going to add a pack of this Kool-Aid pink lemonade for color. I didn't see measurements, so we're just going. Is there a way to get this to? Okay, I got it. Okay, it came out better now. We have added the pure baking soda by Arm & Hammer. Now we're going to add water, cool water. I'm only going to do a little bit because I don't know just going to add maybe a quart. I don't know. This is just... more baking soda. Can you pause it? Or does it like cancel it? If it stops it, you can just stop it. And then I'll just